Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fahmi bin Syahriman and we are Group 17 F3 Engineering Enterprise. So today I will present our project which is pump oil harvesting machine. Malaysia is a major producer of palm oil in the global, and Malaysia palm oil industry is heavily reliant on trained labor. As a result, Ladang KPS plan to alter the harvesting process, and they hire our company to develop a system with leverage current technology to help with the palm oil harvesting process. So our problem statement was to propose a new design of harvesting tool to make the palm oil harvesting process more efficient at the Stenggang oil palm state. In the new harvesting tool design, any improvisation must outperform the present total production level as evidenced by valid analysis, and the design must be functional and cost effective while also taking into account environmental, sociological, and sustainable concern. The objective to achieve was to study the design concept in improvising the harvesting tool and to design a new high productive tool for palm oil harvesting process and to analyze the new harvesting tools and lastly to determine the proper and suitable value for our product. After going through several conceptual designs such as house of quality and also pure chart, this is our final design where the harvesting machine will have to increase the harvesting rate since the harvesting process become this due to the amount of force needed to harvest the palm oil is reduced.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azmil bin Adam, Civil Delivery. I will explain about organization for our group F3EE or Physical 3 Engineering Enterprise. Okay. For our advisor studio is Dr. Shami, and then for this course IDP we have divided our work like for the links in simulation analysis is by Izul, fleet analysis by Fahmi, PNE or professional and ethics, also mechatronic to by Muhammad Nur Hidayat, and then thermodynamic analysis by Muhammad Azmil bin Adam, and for costing or economic by Badrul Azmil, and last for manufacturing is by Izzat Afendi.
Assalamualaikum. I am Izul Nawarif bin Osman and I will be presenting about the components of the machine. And firstly, for the engine support frame or the backpack, it will support the engine and to be carried at the back. And then there is a two-stroke petrol engine which will provide power to rotate the shaft. Next is the flexible shaft that is connected to the engine. It will transfer power from the engine into the shaft inside the pole. And then there's a flexible shaft to pole connector which connects the flexible shaft to the pole. And then next is the shaft itself inside the pole that transfer the power to the cutter. And per pole that contains and protect the shaft from the environment. Next is the handle joint, which will connect the support handle to the pole. And then there is a gearbox and a sickle. Gearbox will contain and support the gearbox mechanism, while sickle will be used to cut the fresh fruit punch. And then there is also a gearbox mechanism that will change the rotational motion into a linear motion for the sickle to move linearly. And lastly, there is a support handle that will provide the user with extra support for the pole. Next is the gear mechanism inside the gearbox. As you know, the sickle is moving with a 10 mm linear motion to cut the fresh fruit punch. So the rotational motion of the shaft needs to be converted into linear motion. The shaft is connected inside the gear train of a bevel gear, which is the bevel gear is also connected to a Scotch yoke mechanism. That way, the rotational motion can be converted into a linear motion, so the sickle will move linearly.
Next part will be the mechatronic components of our machine. We will be using full level sensor system for us to indicate the user how much fuel level is left for the engine. This is because the fuel tank is located on the engine, which is at the back of the user during operation. Thus, it is difficult for the user to see the fuel level in the tank because it is out of their sight. So the implementation of the system will help to solve this problem so that the user know how much the fuel left in the tank before it is finished. The suitable sensor for this system will be a resistive base sensor. This sensor is small, which can be placed in the tank of our engine. It is used to measure the fuel level inside the fuel tank. The next one will be the full digital fuel gauge. This one is to indicate the fuel level measurement from the sensor to the user. Next is the components that we will use to connect the digital gauge onto the pole. A V-shaped bracket is used to hold the digital fuel gauge to a fork clamp, and this fork clamp will be used to mount and hold the V-shaped bracket with the digital gauge on the pole. Is the simulation part. This part is used for us to understand how our fuel level system works. A software will be used to demonstrate the working principle of this system. The software used is the Tinkercad online software. This system consists of two units, which are the sending unit and the gauge. The sending unit will be the resistive fuel level sensor, while the gauge will be the digital fuel gauge. This fuel sensor acts like a potentiometer, and the float moves with respect to the fuel level. As the float moves, the resistance of this fuel sensor changes. For the working principle, when the fuel level in the tank decreases, the float of the fuel sensor, which is connected to the metal rod, will move downward. The metal rod is, as shown in this figure right here, a potentiometer is connected to the float and attached at the end of the metal rod. When the float move upward, the resistance of the potentiometer will decrease and the amount of voltage will increase and lights up the LEDs inside the digital gauge. Simulation circuit for our fuel level system. In this circuit, Arduino Uno R3 is used as the microcontroller. A potentiometer in the circuit is used to measure the fuel level in the tank. The LEDs with different colors are used to indicate the fuel level in the tank. The red LED indicates that the fuel is almost empty. The yellow LED indicates that the fuel is half full, while the green LED indicates that the fuel is full in the tank. So in this simulation, as I rotate this potentiometer anti-clockwise, the resistance level will decrease and the voltage will increase. This increasing value of voltage lights up all the LEDs, indicating that the fuel level is full. And it works vice versa as I rotate the potentiometer in a clockwise direction. The engine that we will use for our machine, it is the two-cycle single-cylinder forced air-cooled gasoline engine. The model is SN33 Sumo brush cutter. The capacity for this engine is 30.5 cc, while the output is 0.81 kilowatt or 6,500 rpm. The ignition plug that is used for this engine is BM6A. The capacity for this tank is 1.4 liter, and the weight for this engine is 3.8 kg. The reason why we choose this engine is because it is light compared to other engine that we found on the internet.
The next part is the production rate of the product. Our company's annual production is 960 units of the harvesting tool produced per year. The production rate can be classified as a medium production quantity as it less than 100 and not more than 10,000 units per year. The working duration is 9 hours per day and 5 days per week. The components and parts used in our product. The handle jar is the only component of the harvesting tool that is actually fabricated by us through the sand casting manufacturing process, which is from aluminum alloy 61 T6. Our company does not fabricate the components except only the handle joint, since doing so would be expensive and costly. Instead, all the components and parts are outsourced, which means that they are purchased from the third-party vendors. The parts that we outsource are such sickle and gearbox, pole, shaft, sensors, engine and flexible shaft, adapter, and bolts and nuts. The fabrication of the handle joint. The figure shows the flow of process of the fabrication. First, in the initial phase of the casting a handle joint, the metal of the handle joint, which is aluminum alloy T6061, is melted in the furnace. Next, an imprint was formed by laying the design in the sand and pressing it to create shape of the component that will be cast. The design is then removed, and the cavity of the mold is then filled with the molten metal. The metal is then allowed to cool until it becomes solid. Then the casting is extracted from the sand mold, which will be broken away from the sand mold. After that, the process of heat treatment is done to strengthen the material, and then it will undergo the cleaning and finishing process. Before the handle joint is transferred to the storage facility, it is inspected to determine its quality or any possible defect that may be occur. Process of the product. There are three main parts that need to be assembled before fully completing the final product. The first part is from bottom. The first part consists of engine, frame, flexible shaft, and pole connector. Then, the second part is at the middle. This part consists of shaft, pole, handle joint, and support handle. And the last part is at the top. In this part, it consists of gearbox and sickle. And after complete assembling these three parts, then the user can assemble all the parts before it can be used.
Assalamualaikum, my name is Badr Azib bin Ramli. So I will continue the presentation on the costing part for our project. Firstly, we will look into the costs involved in our project. There are several costs were considered in the analysis, including the capital costs, labor costs, raw material costs, and operating costs, which consist of overhead, maintenance, and machinery costs, which as stated over here. As for our initial investment for the project, the total investment required for the project to be initiated is around 2 million. This investment considered the capital cost, labor cost, operating cost, and the raw material cost. Then from the calculation of unit selling price and considering the 10% of SST rate, also 40% of profit from the sales, the selling price for our machine was 2,426 ringgit, which significantly cheaper than the Chantas Evolve price mentioned in a journal by MPOB, which cost around 3,800 ringgit. This unit selling price is also slightly cheaper than some existing Chantasivo in the market, which ranging from 2,600 to 3,400 ringgit. Last but not least, the benefit cost ratio calculated from the cost analysis was 1.54, which shows that the project will bring benefits instead of losses. Apart from that, the yearly sales of the machine also will help us to regain back the investment about 41% annually. This means that we will gain back the full amount of our investment for only 3 years. Finally, from the break-even analysis, our company need to successfully sell around 367 units of our product in order to overcome the cost to produce the machine and start gaining profit. From this quantity, the revenue of the break-even analysis is about 890,000 ringgit. Finally, to conclude the costing part for our project will assist in achieving the Sustainable Development Goals. The targeted SDG goals from our project will be SDG 8, 12, and 13, which will promote a sustainable economic growth, sustainable consumption and production, and also helps to combat the climate change.
Next part will be professional and ethics. For our machine, during the operation, it will produce vibration and noise. These vibrations are produced by the engine, which can be transmitted from the machine to the hand of the user. It can cause discomfort and decreases the efficiency of the harvesting process. When the level is higher, it can lead to serious problems such as disease. Thus, we have decided to follow a standard such as the international standard ISO 5349. According to this standard, the vibration exposure level should be lower than 2.5 meter per second square. If the level is higher than this, changes need to be done to modify the vibration so that it is lower than this value. To measure the vibration, accelerometer can be used by measuring the vibration at the holding points at the pole. This vibration can be reduced by using isolator. As for the noise, exposure during work can lead to hearing damage, especially if exposed for a long period of time. This is the standard that we will use for the noise exposure, which is set by the Occupational Safety and Health Noise Exposure Regulations 2019. According to this standard, the limit for daily exposure should be less than 85 decibel. The maximum sound pressure level should be less than 115 decibel. The peak sound pressure should be lower than 140 decibel. If changes cannot be met to reduce the sound level, user should wear personal hearing protectors to protect themselves from the hearing damage during the operation.
Okay, for conclusion, from our discussion, we were able to produce a prototype for the palm oil harvesting model by using material that have been refined with the original shape of the model. And then we can also solve the mechanism and animation part for the movement of our design products by using design software. Also, we can also solve for the analysis part such as cost, manufacturing, fleet, thermo, P3 and P3 PNE, and then mechatronics based on our design products have been set and selected. That's all from our group. Thank you.